Hello again. It is Intro to Physical Anthropology, and I am your instructor, David Leitner. Today, we're going to finish up our discussion of Darwin's thinking and the theory of natural selection by talking a little bit about the interactions between Darwin and Wallace and how their co-discovery, I know I've been talking about only Darwin up until now, but their co-discovery of natural selection is a perfect example of how the scientific process works and why it works. Okay? All right, so let's get started. So, who is Alfred Russel Wallace? Well, he was a field biologist in Indonesia. He came up with his own version of a theory of evolution parallel to Darwin's, okay? Darwin published on the Origin of Species in November of 1859. It was right before this that Wallace was actually interacting with Darwin and coming up with his own theory, and they were having discussions. It was really neat. To learn more about that, I want you to, in a second here, I want you to pause the video and go to the videos and multimedia page for this chapter and watch this movie here, The Origin of Species, The Making of a Theory. This is the story of Wallace and Darwin's relationship here. It's very brief. I think it's about a half hour long. Raises a lot of interesting points that will also help clarify what natural selection is as well. So it's not just about Darwin and Wallace, it's about natural selection. So if you need some more sort of examples to help you understand it, this is a great place to get it. When either you can keep watching right now or you can pause and go watch the movie now. It doesn't matter to me actually. But I will, if you do pause it, come back, because I'm going to have some questions for you to think about. You don't have to write them up. It's not an assignment, but think about them. See if you can answer them. All right. So here's the timeline of their discoveries. Obviously, Darwin is older than Wallace, right? He's born in 1809. Wallace isn't born until 1823. So by the time Wallace is a small child, Darwin is going on his voyage on the Beagle, okay? And he is coming to these various conclusions for long about 30 years. He's sitting on this idea, just developing it slowly and slowly and slowly and gathering more and more data. Wallace, on the other hand, whereas Darwin came from a privileged background, Wallace did not. He wasn't poor, but he didn't have the family resources to draw upon that Darwin did. So in order to fund his expeditions, he had to sort of collect samples that he was, not samples, collect specimens that he would then preserve and sell when he got back to England. He, in the process of doing this, though, starts making these observations that chiefly that he finds similar but distinct species on nearby islands. Okay, so similar species, but each island has its own distinct version. This is very similar to what Darwin saw in the Galapagos. After he got back, he realized that the islands that different species came from kind of matched up with the species. So they're both working with this idea and a lot of the same observations completely independently. At this point, Darwin doesn't know anything about Wallace. Wallace knows Darwin a little bit because Darwin's a well-known naturalist by the time Wallace is an adult. But they haven't corresponded. They haven't met. Finally, they in 1858, year before Darwin finally publishes Origin, he gets a letter from Wallace saying, I have this idea, and since you're like the chief, like the primary, most renowned naturalist in England at this time, somebody told me you're working on some similar ideas. I just wanted to run this by you to get your opinion. Remember, I talked about science being a communal effort? This is one of the ways that happens. Well, Darwin reads it, and suddenly he jaw drops. It's like he's reading his theory, completely independently discovered by this young man. And now he's got a choice there. He can just burn the letter and nobody ever knows about Wallace. And instead, what he does is, through some of his friends who finally have been bugging him for years to publish this book, they finally are like, okay, now you have to publish this book. You don't have a choice. You've been doing the research long enough. You have enough evidence. Just publish the book. And what we'll do is we'll arrange a joint reading at the Royal Society. Wallace couldn't make it because he was in Indonesia at the time. So Darwin agreed to read Wallace's letter after he read his own, or Wallace's paper after he read his own sort of summary of his book. And they were recognized as co-discoverers. Now, over the course of history, because we have a bias towards wanting stories of great men, individual great men, that Wallace got kind of erased for a long time and forgotten. He's recently been sort of resurrected again, and we are trying to sort of proselytize, I guess is the best word, trying to give him the credit he's due. He did not have as much evidence or as detailed a theory as Darwin did. Of course not, because he hadn't been doing it for 30 years, slowly collecting information. Darwin's 30 years weren't wasted. He was building the case for his theory, trying to make it as airtight as possible. And it paid off. So both men independently coming up with similar observations about the world that point to similar explanations. That's a pretty good sign that a theory might be correct. That's a pretty good sign. Anytime you have multiple independent lines of evidence pointing at the same thing, you can be more confident that that is the correct explanation. So, that said, let's think about some things with this film. First, Darwin and Wallace came to and developed their theories independently, and each one developed distinct lines of evidence, observations, and facts. Try to list some of those. See if you can remember what some of those were. It's okay if you don't remember them all, but try to think about what they were. You can hit pause now if you want before I go to the next one. The natural origin and evolution of species best explains the diversity and relatedness of organisms. It also is the best explanation for the sequence of change found in the fossil record. Okay, so it represents, it explains modern diversity and relatedness as well as ancient diversity and relatedness. Why? Why would it sort of show up in the fossils and the modern contemporary organisms? Natural selection works on variation among individuals in a population. We're going to come to this later in the semester. Natural selection works on individuals. Evolution is a property of populations. Variation of certain traits results in differential survival and reproductive success. We call reproductive success fitness among individuals. And this causes populations to change over time. So in the film, what examples did they give of this? Take a minute to think and reflect back on that. We can construct evolutionary history by comparing living organisms with the fossil record of extinct organisms. Think of an example of this, either from the movie or from another source that you have. Observing the natural world raises questions. These questions have tentative answers that we call hypotheses, which can be tested against other observations, facts, experiments, evidence, etc. When enough testing supports the hypothesis, it can become a theory. How did Darwin and Wallace go about testing their hypotheses? Good theories like natural selection require multiple lines of evidence from observations as well as experiments. As evidence accumulates, some hypotheses will be revised or set aside while others allow us to make more detailed inferences. What were the main lines of evidence Darwin and Wallace used? How have subsequent scientists tested their hypotheses? Think about what that might be. It's okay if you don't have the answer, but just think about it. Evolution by natural selection is sometimes described as survival of the fittest. Do you think this is an accurate description? Why or why not? I'll give you a hint here. I often call it survival of the fit enough. See if you can figure out why I do that. I'll explain it in the future. Genetic variations arise by chance mutations, providing the raw material upon which natural selection can work. Variations that lead to greater reproductive success in a particular environment are passed on to subsequent generations. Would it be accurate to say that evolution by natural selection is a random process? What parts of the process are random, if so? What parts are not? Finally, in natural selection, traits interact with the environment to increase or decrease an individual's chances of survival and reproduction. Does the environment cause the variations? Think about that. Adaptation results from the accumulated effects of natural selection. Does this happen because individuals adapt to their environments? Remember, the key word here is individuals. Do the individuals adapt? If individuals don't adapt to their environment, how does adaptation actually occur? And at what level does natural selection occur? Well, I just told you. I hope you remember. How does it work? So that's enough for today. That'll wrap up our sort of natural selection. For now, we're going to come back to natural selection in one of the later chapters, not just to review it, but kind of expand our knowledge of the forces and how it works. But in chapter 3, we're going to start talking about the building blocks of evolution, DNA, and how DNA and various cellular processes of replication and reproduction, protein synthesis, all of that come together and are the gears of evolution that drive it. Thanks a lot. Have a great time and take care of yourself. Bye.